Hello everyone, and thanks for joining me again today for another session of Me Programming Daily. Now, during the last session, I had a pretty turbulent time with the rendering engine. I don't remember exactly what happened, but I had a quieter session in the weekend off camera, during which I inverted the fold that was causing us some, where is this? That was causing us some problems with this fold. It used to be fold R. That was causing us some problems with identifiers not existing in the list of origins or in this map, because naturally they wouldn't. If we're going bottom to top or right to left, some identifiers might not exist in the map if we're here and the identifier is here. So I resolved it with fold L. I also fixed the issue where the declared origin O of a block did not really correspond to what we were seeing on the graph. Oh, yes, I remember. This was the main problem. So when I rendered a block at position 0, 0 overlapping this, it would be rendered here as opposed to end. So this is all fixed now. The fix wasn't very complicated. I'm not sure why it took me so much time during the last session. It only took this sign to be reverted or reversed from plus to minus. We changed the fold. I modified it just a handful of things, and things are back in order. But now everything is upside down, so to speak, so that 0, 0 is not here at the end, 0, 0 is here, and we move down and right. Anyway, during today's session, what I want to tackle is a problem I've been thinking about before I recorded the last session. And I don't have a good idea how to solve this yet, but you may have noticed some additions to the type signature of render and render prime, I think. And this is a list of doubles. I'll explain. So you remember during one of the last sessions we added a list of connections. These are the gamma connections, connecting right-hand side blocks with their parents or something above the parent. The conditions are not fully specified yet, but they are very strict to begin with. So it's either a parent or something on the branch that the parent sits, but they are not enforced, they're not validated. So I'm just keeping them in my head for now. This is resolved, so we can remove this comment. So the issue I wanted to illustrate is if I run this, I think action 5 here is going to connect to question, sorry, this guy, this question. So we connect from 6 minus 2, which is 0, 3, 6, 0, minus 1, minus 2. Yeah, so this is the origin. Oh, sorry, here's the origin. I think, yeah. 0, yeah, I should be pointing from the middle. I changed the rendering. 0, 3, 6, minus 2. So from 6 minus 2 to 0 minus 1. So 0 is here, and minus 1 is question. So we need to connect these two. So let me maybe do some drawing to illustrate the issue better. So is it going to be a drawing session? Probably yes. But if I can, I'll squeeze in some more programming into it. So the graph looks like so, or the diagram looks like so. If we had the connections of, oh, sorry, if we had the connections, of course. See, this is why we need a quality rendering engine for diagrams. I'm just going to draw all of it, but question leads to another question and also to this action 5. Somewhere here, so let's pretend these adhere to Dracon rules. The arrow isn't there. So if you want to connect action 5 with question, the connection would look something like this. Give or take. Right, something like this. Okay, so the problem is relatively simple if the width of this action is known, or in general, the width of the right-hand side of this question is known. But it's mostly unknown. Well, we don't handle scenarios where the width is non-standard. Well, I should have used the word standard. If the width of the right-hand side is standard, meaning default bounding block width, it's simple. We can sort of calculate where this line should go. But if this right-hand side is a little bit more adventurous, like more things are happening here, maybe there's another action, or maybe there is a question that branches out, this line is going to be more interesting, and it would be quite a challenge to calculate where these coordinates should be, given the new width of the right-hand side branch of this question. That needs to be determined and calculated. So I'll give you an example. This can be dismissed now. Let's say action 5 is preceded by action or if action 5 becomes action 5b and is preceded by action 5a, and sorry, action turns into 5c, it has 2 actions before it. Let's just try to run it. It looks sort of more complicated. And just out of curiosity, let's add maybe 2 more. Oops. So the end is being pushed down. That's great. That's what we want. And still the connection from 5e to question is relatively simple. The only thing that really changed is the length of the connection. But the x coordinate of this line stays the same. Now, what if we make it a little bit more interesting, and instead of action, we turn this into a question that branches out. And here, let's place action 5c left. And here on the right hand side, we'll place action 5C right. And all of a sudden, that connection becomes kind of tricky. And so let's maybe illustrate this with a drawing. Or maybe let's make it a free line, so you'll have to excuse me. So the connections would look something like this. I'm not very good at this. We go here, 5A. Let's pretend all these lines are straight. Oops. I hope you get the idea. We return here. We go to action 5E, and now this line all of a sudden does not go up here. It needs to bypass this action 5C right, and only then it is allowed to flow to question. This is some very clumsy drawing, but I hope you get the idea. So that connection will have to bypass this action 5C right. I have an idea how to implement this, and it is just by basically keeping track of the max x used in the rendering of the previous blocks. And whatever the max x is, we just need to add to it whatever margin we want for the connection, and we should be fine. Let's see if that really works. Let's dismiss that beautiful work of art. So this is why I've been keeping track of this max x, or a collection of max x's. I just want to make sure that I understand how the connections are drawn. So I started preparing how this max x would flow through this whole rendering pipeline. What I came up with is single entry in that list, 37, just a random number that's sort of easy to spot. Yes, 37 inserts here. So we'll obviously start with 0. And let's continue down this path. So this is where the actual session should start. I hope you have your drink of choice ready. I have my coffee here. And so we're going to check if that connection can be populated with the correct values of max x. Where max x is the furthest a block goes looking from the perspective of an x-axis. But here I already see a little problem. It should be this. That shouldn't change anything though. Just in case. So now let's figure out who and where should populate that list. So every render gets a max access. So let's assume that we only populate this max access with origin. Let's just do it for start terminator and terminator. Just because this is the easiest. And since the origin now is in the middle of a block, we need to add default bounding box width times 0.5. Because for now we're assuming that every block except of the fork is of equal width, just to simplify everything. So now we expect 2 elements in this list. And we don't get anything. Let's see why. Okay. That is because... do I know? No, I don't. Oh, this isn't right. I hope. Oh, perfect. So we have 1.5, 1.5. This is this is going to be a bit tricky to memorize. But it's fine. So let's leave these untouched. The actions, the headlines, addresses. Let's focus on the fork. So fork really has three elements. The question, the left-hand side, and the right-hand side. So the question, we probably don't even need to add to max access. However, left-hand side, we probably should. Because just like here, there could be some forks on the left-hand side that would shift the right-hand side to the right. So technically, we don't really need to worry about the fork. Because fork is just a question, and we don't really care about the width of a question, because the right-hand side, empty or not, will always be further to the right. Oh, that's the other thing I had to change from plus to minus when I inverted the fold. Okay, so where were we? Let's do the same thing for actions. And this will already shed more light on the max access. I believe. Oh, that is great. So we have 1.5, which is this, and then 7.5 and 7.5, which is very interesting. So this is it. let's go from the back. So that's the end. Yeah, because this is appending to the front, so it will be inverted. So 1.5, 1.5, 1.5. It's these three. Then we probably should expect what I thought 1.5 still, but they say 4.5. So that's this plus 3, so this. Then 4.5 again. And then 7.5, 7.5, 7.5. Let's see, there should be 3. 1, 2, 3, yes. And then 10.5 here. And then back to 7.5, 7.5. And then 1. Oh, I forgot. We don't calculate questions. So whatever it just calculated should exclude questions. So let's calculate the entries. We should have this the number of entries equal to the sum of the number of actions plus start terminator and terminator, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. So now, I don't want to make this session too long. So let's try to maybe define a temporary test gamma connection that would bypass the blocks and other connections. That is very tempting. So our connection is 6 to minus 2. Sorry, 6 minus 2 to 0 minus 1, which is 0, 3, 6 minus 2 here. Oh, and that is wrong. 6 minus 2. It's not minus 2. It's minus whatever the length of this is. But we are connecting to 0, 1. Okay, let's quickly see. Gamma connections. Where do we modify gamma connections? Oh, so this is wrong. This R0 is wrong. Yes, because, okay, we got an error. Let's see if we can do this. R0 X. That's right, that should be P V R0x R0y. So here, origin is constructed a little bit differently. P2 R0x R0x, and then instead of R0y, we need O, or the initial y, minus the height of everything. We have width, and we have height. Okay. Height in units. And that would be the height of R. I think so. Let's see. So we're expecting to see 6, correct? But not -2, but minus 2, 3, 4, 5, 6, 7. Yes. Okay, so we fixed that. Later on, I'll modify this list of doubles to just a single double, but I'm just very curious how the list is being built up. And this also helps me validate if the values are correct, and they seem to be for now. Okay, so we can't draw a straight line, but we can construct something resembling a gamma connection, leveraging these points. So when we render prime, we return this elaborate tuple of diagram, origins, max axis, and also connections. That list of connections we can, I believe, modify. That's the head of Z. So here we'll just do I can remove this. It was just for troubleshooting anyway. So I'm expecting no changes whatsoever because the gamma connections only has one element. And now let's try to do some manipulations. We know this is going to be a gamma connection, and thanks to Dracon properties, we can sort of reason about the shape of the line we're going to draw. So origin is going to flow to a point just underneath. So let's call it gamma origin X, gamma origin Y, gamma destination X, gamma destination Y. We have P2. We don't seem to have P, but that's easy to change. Let's just see what's to import. Oh, I think that's point. Yes. So where are we? Here. So that is going to be midpoint 1. It's going to be the same X as origin, gamma origin Y minus say 0, 1. It doesn't have to be super precise. Let's not worry about this yet. I think we'll have to extend this return type because I'm no longer interested in tuples. I'm interested in, for now, one-dimensional array or one-dimensional list of points. So for now, we're assuming that we're only dealing with one connection. So here is going to be Z. Here it's going to be gamma origin, gamma midpoint 1. We just need to print this. Let's rename this. So if this compiles, the last return value we should see is 3-pointer. 1, 2, 3, perfect. So these 2 points are correct, but this is not what we came here for. We came here for the next point. That is going to indicate how far to the right should the point extend. And what I would expect to see is wherever the max was, 10.5, say plus 0, 1. So 10.6 should be the x coordinate of the next point. And y stays the same. I think maybe maximum. $16.6, okay. Why is that? Oh, but because okay. We shouldn't be adding this. Because this is absolute maximum x. 10.6. Beautiful. So we've drawn a connection from here to here, then to here. Just beyond this. Now let's go up. So it should be gamma destination y. This will be tweaked, of course, because we need to remember that the points we operate in or with, the origins, point at the middle of a block. So that's not exactly what we want, but it gives a good idea of the situation. Oh, and that's it. We just need 3 points extra. 1, 2, 3. and the fourth one is somewhere here. For now, we can just simplify to this. And we can make some tweaks once we render this. Okay, so we have 10.6 minus 7.1, 10.6 minus 1, which would be somewhere here. And the last point is 0 minus 1. The y coordinate doesn't change, x coordinate changes. Okay, so we don't have a visual, like a graphical vector representation of it, but looking at coordinates, they look correct to me. Now, a number of things we'll have to address during the next session. This is not the right placement for this function. It should be wherever we add connections to that list of connections. Gamma connection ID. And that should modify the width and the max x of our current branch. But we can address this during the upcoming sessions. For now, I'm pretty happy with the result. So yeah, let's wrap it up here for today. I would like to thank you all for sticking with me, for your patience, and I wish you a beautiful autumn day. I hope you survive the gloominess and the rain and bad weather, and yeah, take care of yourselves.